Yesterday, got introduced to the periodic table and kind of some introduction of how that's all laid out. Today, we're going to continue to talk about that as far as the placement of metals, metalloids, and nonmetals on the periodic table. And so, if you look at the one that's on the screen, or you can grab one of the ones that's on your table as well and look at those, the color coding might be a little bit different, but it should still show you the same information. The one that's here on the screen shows you in yellow the metals, purple metalloids, and green nonmetals. And so you see that purple stair step of the metalloids. It kind of looks like a staircase going down. That's the dividing line between the metals and the nonmetals. And so if you can remember that everything to the left of that staircase is a metal, everything to the right of that staircase is a nonmetal, and the staircase itself is a metalloid. The one exception, as you can see on the chart on the screen, is hydrogen. Hydrogen's a non-metal, but it is on the metal side of the periodic table. So don't let that throw you off. It's the exception to the rule. You're going to need to know where the placement of the metals and nonmetals and metalloids are. And as far as just kind of generally on the quiz today that you're going to have after you finish taking these notes. And so remember, all that yellow to the left of the staircase, metals, the green to the right of the staircase is nonmetals, and the staircase itself is metalloids. So we're going to talk a little bit about the characteristics of each one of these, and then we're going to talk about what an ion is before we close. So let's go on and talk about some of the characteristics of metals, nonmetals, and metalloids. Let's look at metals first. Metals have a high melting point. This is the temperature where a solid turns into a liquid. And so we kind of know that already. Metals have a high melting point. You can throw metal in the fire. It's probably going to get hot. You're probably not going to be able to get a fire hot enough to actually see that metal melt. They also have a high luster. This just means that they're shiny. Luster is how shiny an element is. And so again, that's one that we kind of know right off the bat. If we remember the word luster means shiny, we can know that metals have a high luster. They're solids at room temperature. The one exception to this is mercury, but all the others are solids at room temperature. A couple of words that you may not have heard before. One is metals are malleable. This means that they can be hammered flat. And so that's why we can use metals for roofs or even for cars and things like that, because it can be flattened out into sheets. They're also ductile. Ductile means that they can be pulled into wires, and so they can be stretched out and become very thin. And then they have a high conductivity. Conductivity is the ability to transfer heat or electricity to another object. And so metals are very good at transferring electricity. Electrons flow very easily on them. That's why we use them for wiring in our houses and our computers and things like that. And they also transfer heat very well. Again, that's probably something you kind of just know from cooking, or if you've ever touched a piece of metal that's been sitting in the sun. All right, heat conducts very well, as well as electricity, in metal. Um, let's look at the reactivity of metals. And so how reactive they are based on where they are on the periodic table. Basically, on those on the left-hand side are very reactive. You remember column 1 has one electron on that outside ring that it wants to get rid of. And so it's going to react with other things very easily to get rid of that electron. As you move across to the left hand side, or to the right side of where the metals are, they become less and less reactive. As those electron rings become more and more full, or closer to being full, they become less reactive. Metals are usually going to lose an electron when they react with another element, or when they bond with another element. They want to get rid of that electron. And so as we talk about ions, that'll be important to know that metals are typically going to give away one of those electrons that they have to get rid of. So nonmetals, and some characteristics of nonmetals. They're basically the opposite of metals. They're not very shiny. They're poor conductors. Electricity and heat do not flow well through them. They exist as solids and gases, bromine being the only liquid. The solids are brittle and dull in color. They break apart very easily. That's basically what brittle means. They can be many different colors, and they have a very low melting point. They go from a solid to a liquid at a low temperature, much lower than what metals would. And so as you look at the reactivity of nonmetals, kind of works the opposite of metals. And so they start off low and then move towards high as you go left to right, with the exception of row 18. Row 18 has a very low reactivity because that outer shell is full. They don't need any more electrons. Nonmetals will usually gain or share electrons when they react with other elements. And so if you look at row 17, it has 7 electrons on that outer ring. It only needs one more. And so it's going to steal one from another atom in order to get that. Those 14 and 15, they're usually going to share theirs in order to fill up their rings. Some important nonmetals, some things just to remember. Carbon is an important element for life. It makes up living organisms. And so carbon is in every organic substance. We also have the noble gases, group 18, what I was just talking about a minute ago. They're very non reactive, have full outer shells. And so as you kind of move across the table, they're kind of an exception to the rest because they play by their own rules, so to speak. They don't play well with others. And then there's metalloids. If you look on a periodic table that maybe you have there on your desk, you see that staircase between the metals and the nonmetals are the metalloids. And just like physically they're in between the metals and nonmetals, characteristically they're also between them. They have some characteristics of metals and others of nonmetals. For example, they're solids at room temperature, like most metals are, but they're brittle. They break very easily, like nonmetals. They make good what we call they're semiconductors, and so they conduct electricity and heat, but not to the same degree that metals would. They're not as good of conductors as metal. They're better than nonmetals. This is very important for like computer chips because you might want something that conducts electricity under some conditions but not others. So, for example, something that conducts electricity until it gets to a certain temperature, and then it would stop conducting that electricity, and it kind of shut it down to protect the computer. The most common example that we have of a metalloid is silicone. It's in sand, it's in glass, it's used in computer products, and so silicone is kind of all around us. Last thing we're going to talk about today is ions. Ions form when an atom gains or loses an electron, and it forms during an ionic bond. When two elements are bonding together, one will loses an electron, the other gains electrons. And so you see an example here of sodium. Sodium's in that first group or family, first column on the periodic table. You see it has 11 electrons. And so on the left-hand side of your screen there's a complete neutral sodium atom. And so it has 11 electrons to match its 11 protons. It wants to get rid of that so that it can have a full outer ring. And so if it gives up that one electron, it becomes a positive sodium ion. The reason that it's positive is because electrons are negative. As it gives away an electron, it has more protons than it does electrons, and so it has a positive 1 charge. And so those first two columns or families are going to give away their electrons easily to be able to have that full outer ring. If you go to the other side of the periodic table and look at groups 16 and 17, they're going to gain electrons easily. They want to get more because group 17 has 7 electrons on that outer ring. So it wants to gain one and it becomes a negative ion. And so the reason it becomes a negative ion is as it gains an electron, it then has more electrons or more negative particles than it does positive particles. And so it becomes a negative ion. And so those 1 and 17 are going to form ions and bond together very easily. Groups 2 and 16 are going to gain or lose electrons and bond together very easily. And so we'll look at those. We'll talk about metals and nonmetals. When they bond together, they form what's called an ionic bond. So when something from the left-hand side of the table and the right-hand side of the table form together, it's an ionic bond. And we'll look at more of that in the upcoming weeks. But for now, make sure you know that an ion forms when an atom gains or loses an electron. Go ahead today and go ahead and do that quiz. Finish getting your notes. There's 5 questions on the quiz. You can take that. It's open note. And then you'll start working on filling in those worksheets that we're working on to get familiar with how to read the periodic table.